This is College Algebra 5.8, Partial Fractions, the first video, and we're on page 511. Now, partial fractions, you really don't see much of what is called partial fraction decomposition until you get to about Calculus 2 when you're doing what is called integration. But the book starts out giving you a little bit of an idea of what goes on with it, so that's what we're going to look at today. So if you look at the example they give us, 4x minus 13 all over 2x squared plus x minus 6. When you simplify that, that simplifies to 3 over x plus 2 plus negative 2 over 2x minus 3. Okay, so when you look at that, what we've got is if you were to take this here and add them, find common denominators, bring everything together in one fraction, you would end up getting this expression right here. Okay? So what we're doing here is I'm giving you basically, well, for lack of a better word, the answer when you add your fractions, and I want you to go backwards to decompose the answer into what you originally had. Okay? So this right here is each of these fractions here are called a partial fraction. So this is a partial fraction and this is a partial fraction. So the entire thing is called a partial fraction decomposition of the rational expression right here. So we're going to learn how to go from here, our rational expression, to making partial fraction decompositions. So at the bottom of page 511, it gives us some procedures, and it assumes that we're going to have, again, a fraction, and we'll call it the numerator p of x, the denominator q of x. You've seen that before in some of the earlier work we did. So the p of x is the numerator, q of x is the denominator, and one of the rules is you cannot reduce this. There are not common factors of the p and the q so that you can start canceling things. Okay, so it says here, first point is if the degree of p of x, if the exponent of p of x is greater than or equal to the degree of the denominator, where you add the exponents together, if this degree is greater than this, you divide the two, and you decompose once you do that, but that's the first step. On the other hand, if the degree of the top one is less than the degree down here, such as this one here, the degree on this one is 1, the degree on this one is 2, so because the degree on the top is less than the degree on the bottom, then we factor into linear factors and go ahead and find the partial fraction decomposition based on that. Okay, so the second step, if the p of x is less than, if the degree is less than the q of x, that's what we're going to work on first because that's kind of the more difficult way of doing that. So we'll go ahead and do that, and then we'll follow steps 3, 4, and 5. And when you look at the steps 3, 4, and 5 in the table, they're a little bit difficult to figure out. So rather than do all that, I'm just going to show you how we go from a rational expression here to a partial fraction decomposition here. So we're going to use the same one, and we're going to decompose it and get this here. So before we do that, let me make sure you got that this is an x here. It doesn't really look very x-ish here. Okay, so again, notice that my numerator, my p of x, is got a degree less than my denominator. So we're going to figure this out based on that information. So first thing we're going to do is we're going to take our denominator and factor it. So we'll leave our numerator the same. So when we factor our denominator, using the procedure that you know, 2x squared plus x minus 6 equals 0. Go ahead and factor that. That's back algebra 2-ish, so you should know how to do that. And we get x plus 2 and 2x minus 3. Okay, so once you have it simplified, and not only simplified, you have to have it simplified into linear factors. So this makes a straight line and this makes a straight line, so therefore they're linear. We cannot have exponents on any of these terms. We could have an exponent here, x plus 2, the quantity squared, but we can't have like x squared plus 2 or anything like that. And like this here, we can't have 2x squared plus x minus 6. So we have to factor it into two linear factors. Once we do that, and again, this is just following a method, we're going to put our x plus 2 here. We're going to put a plus sign, and we're going to put a 2x minus 3 here. All right, what we're looking for is the numerator. So we don't know what that numerator is, but we do know that it's a number. So we're just going to call it a capital A and a capital B. Okay, so once we find what A and B are, we put those numbers up there for A and B, and that will be my partial fraction decomposition. So I know actually my A is going to be 3 because that's the answer, and B is going to be negative 2. So that's what I'm looking for. A is 3, B is negative 2. So you're not going to be given this information. You're going to have to figure out what A and B are all by your little lonesome. But this just gives you an idea. So you're going to set it up like this. You're going to split your denominators up. You're going to ignore this, and you're going to put an A and a B. All right, in order to add A and B together, in order to get them over one fraction is our goal here, and I'll explain why that's our goal in a minute. And we need to find common denominators. So remember a long, long time ago, and this is kind of where it pays off, I look at this and say, what am I missing here that I have here? I'm missing a 2x minus 3. So I'm going to put A times 2x minus 3 there. Top and bottom. And on the other side, I've got a B, and I'm saying, okay, what am I missing here that I have here? Well, an x plus 2. So I'm going to multiply top and bottom by x plus 2. Okay, so once I'm to this point, okay, I'm just going to move this out of the way here. And again, it's equal to this here, so I'm going to rewrite that, 4x minus 13 over x plus 2 over 2x minus 3. Okay, so I found common denominators, and like I said, so when I'm at this point, my common denominator here is the same as here, which is the same as here. Now I'm going to bring these two together. I'm going to make that A over 2x minus 3 plus B times x plus 2, and this is one of the reasons why you find a common denominator, so you can bring your two fractions together and make it into one fraction. And again, it looks like a lot of repetition in my writing, but I just want to keep everything together so there's no question of what is happening here. Alright, so I didn't do anything weird. I just did some things that are kind of new, taking a bunch of old stuff that you've done in the past and getting that for my answer. Now, this is why we found common denominators. When I have a common denominator here and a common denominator here, alright, let's just take a break from this problem. Let me just give you an example with real numbers. 2/3 equals x over 3. Okay, that denominator is a 3, that denominator is a 3, which means this equals this, right? Same thing is true with what I have right there above. If my denominators are the same, I can get rid of my denominators. So alright, so now I have an equation with no denominators. Okay, so next step I'm doing is I need to find out what my A and my B are. So what I'll do is I'll look at my A first and think, okay, what do I need to put in here for X that'll make this 0, so that when I would take 2 times a number minus 3, this is 0. So then this 0 times whatever A is going to be 0. So this whole thing will turn into a 0, which means I'll just have this equals this, which means I can find B. Alright, so what I'm going to do is, what can I put in here for X to make 2x minus 3 0? So you set 2x minus 3 equal to 0. And I get 2x equals 3 and x equals 3 halves. So when x is 3 halves, this here will be 0. Okay, so what I'll do now is I'm going to substitute 3 halves in for x all the way across the board. Okay. Alright, so now let's look at what we've got left here and go ahead and solve it. This right here, multiply this, would be 12 over 2, which is 6. This here will all cancel and be a 0. And 3 halves plus 2 would be 7 halves, so that would be 7 halves B. So we have negative 7 equals 7 halves B. Divide both sides by 7 halves. That cancels. And negative 7 ends up being 2 over 7 equals B. So that gives me negative 2 equals B. So B equals negative 2. Okay, so if you go way back to the top, where we first started talking about this, the number that goes in the numerator position is going to be a negative 2 when we replace our B. Alright, so we do the same thing with our A now. Okay. Okay, so I just brought some stuff up there for you to look at from past. So we found out our B right here is negative 2. Okay, so now what we're going to do is we're going to find the A. So we found the B is negative 2, now we're going to find the A. So what we're going to do then is look over here and see what number can we put in here for X to make this 0, and then that'll cancel our B out, and all we are looking for then is A. So again, we'll get rid of our denominators, and I'm going to rewrite this whole thing. Get this out of the way here. So we have 4x minus 13 equals A, 2x minus 3 plus B times x plus 2. Alright, so we're going to replace this x right here with a negative 2, and all the other x's with negative 2's, because that's going to make that 0. So 4 times negative 2 minus 13 equals A times 2 times negative 2 minus 3 plus B times negative 2 plus 2. Alright, so let's go ahead and solve this. Alright, so we have negative 8 minus 13, which is negative 21. And that's going to be A times negative 4 minus 3 is going to give me a negative 7. And then this here is going to be 0, so we just have plus 0. So negative 21 equals negative 7A. Divide by negative 7, and you see what we're getting here. We get A equals 3. So now I go back to my equation up here at the top, my very beginning. And my A here is going to be a 3, which that's what that is right there. So that was the partial fraction decomposition of this, making it into this.